Welcome back, everybody. Today we're looking at solving and graphing one-step inequalities, specifically using the multiplicative inverse. So let's begin by doing a very quick review of a one-step inequality using the additive inverse. So if we remember, additive inverse with a one-step inequality is written something similar to this, where we have y minus 3 is less than 5. And to solve a one-step inequality using multiplicative inverse, or rather additive inverse, all we do is we eliminate the constant that is on the same side of the inequality as our variable. We need to isolate the variable. So we're going to add 3 to both sides of the inequality, and we end up with y is less than or equal to 8. And then we would graph this on a number line. We'll just do a very quick graph. Here's my 0, and I'm going to count by 2's this time, just so I can get up to where I need to be. So I have my values on the number line, and I have y is less than or equal to 8, so I'm going to put my value circle above the 8, and since it's equal to, I'm going to fill in my circle representing that 8 is an answer to this problem. And it says y is less than, so I'm going to draw my arrow to the left. So this is how we solved a one-step inequality using the additive inverse. So today we're going to look at solving a one-step inequality using multiplicative inverse. And just like we did with the additive inverse, I'm going to show you the method by comparing a one-step inequality and a one-step equation. And we're going to look at the similarities and differences in solving those types of problems. So first let's look at solving a one-step equation. If I were to use this, 3m is equal to negative 9, then the way that I would solve this using the multiplicative inverse is I would take 3m, and I would realize that in order to solve this, I need to isolate the variable m. And to do that, I'm going to multiply both sides of my equation by the multiplicative inverse of 3, or in other words, we're going to multiply both sides by the reciprocal of 3. Now remember, 3 is a fraction, as is negative 9. Everything can always be turned into a fraction. And what we're going to do is we're just going to multiply this out to eliminate the coefficient of m. On the left-hand side, we're going to end up with 1 times 3 and 3 times 1, which of course is 3 over 3, which is a value of 1. So we don't need to write that, so we just write the variable m. And we're going to, on the right-hand side, we're going to multiply as well, and we end up with negative 9 over 3. Now negative 9 over 3, of course, we can simplify that, and when we do that, we end up with our answer of m equals negative 3. So that's solving a one-step equation using multiplicative inverse. So we're going to compare that to solving a one-step inequality using multiplicative inverse. So we're going to divide our page here. So let's start with the exact same thing. We're just going to change the equal sign this time to an inequality, and it can be any inequality. I'm just choosing greater than in this case. So just like in our previous problem, we still need to isolate the variable because that's the goal of solving inequalities and equations. To isolate the variable, I'm going to multiply both sides of the equation just like I did with both sides of the inequality, just like I did with the equation, by the reciprocal of the coefficient of m. So since the coefficient of m was 3 over 1, I'm going to multiply both sides of the inequality by 1 over 3. Just like with the equation, when I multiply, I end up with 3 over 3, which is a value of 1. So I just write the variable m to represent 1m, and I have greater than, and I'm going to multiply straight across here, and I get negative 9 over 3, just like we did with the equation. Our last step, of course, would be to simplify negative 9 over 3. Negative 9 divided by 3 is negative 3. So we get the exact same value, the only difference being one of them is an equal sign and the other one is an inequality. Lastly, we would have to, of course, graph our answer for the inequality. So we would create a number line and put the value with the corresponding arrow on that number line. So we're going to have 0, and we'll have -1, -2, and -3. We'll just put a +1 on the other side just for balance. And if we look at our value, we had m is greater than -3. So we're going to start at -3. That's the value that we were given. We leave the circle open this time because it's just greater than, not equal to. So that means I cannot put -3 in as a substitute for m because I'd have -3 is greater than -3, which doesn't make sense. So I leave the circle open, representing that that is not a value I can use. The next step would be looking at which direction do I draw my arrow. And if we read the inequality, it says m is greater than -3. So I'm going to draw my arrow to the right. There's our first example of solving a one-step inequality using multiplicative inverse, and I want to do one more because there is an instance where something different happens, and that's what we're going to look at next. So for our next problem, I want to show you once again the comparison between using an equation and an inequality, just so I can show that there is sometimes a little bit of a difference in the way that something is solved. What we're going to do is we're going to look at a situation where the coefficient of the variable is a negative. So for example, if I said -2m is equal to 8. If I'm solving an equation, it's a very straightforward process. Just like in our previous problems, I'm going to multiply both sides of the equation by the reciprocal of my coefficient. So my coefficient is -2 over 1, so I'm going to multiply both sides of the equation by 1 over -2. When I multiply by 1 over -2 on the left-hand side of the equation, I'm going to be able to cancel these out because it creates a value of 1, and I can just write that as m. On the right-hand side of the equation, I'm going to have 8 times 1, which is 8, and 1 times -2, which is -2. So I'm left with m equals 8 over -2, which we can simplify, and that becomes m is equal to -4. The difference with a one-step inequality is that when I start with -2m, and we'll just use less than or equal to this time, if I have -2m is less than or equal to 8, the step is still the same. I'm still going to multiply both sides of the equation by 1 over -2, which is the multiplicative inverse, or the reciprocal, of -2 over 1. And I multiply both sides of the equation by that value. When I multiply, just like in the previous problem, on the left-hand side, these values will equal 1, which is written as just m. On the right-hand side, I'm going to have 8 over -2, just like in the equation. But here's where things start to change. One of the rules that you need to remember, and I can show you how this works in a minute, but one of the rules that we need to know is that when we multiply both sides of an inequality by a negative value, in this case our negative value is -1 over 2, or 1 over -2, when that happens, when we rewrite the inequality symbol, we change the direction of the inequality. Okay, once again, if I multiply both sides of my inequality with a negative value, okay, I have my -2, then the inequality, the direction of the inequality symbol, changes to be going the opposite direction. And I'll prove that to you, and I'll show you why that works in just a second, but let's just finish this problem first. So the next thing we would do is we would simplify, and we would say m is greater than or equal to -4. And of course we would have to graph this on a number line. So we would have our number line. Let's have our 0 way over here this time, just so we can fit everything in. And didn't quite fit everything in, but it was pretty close. and we would graph this the same way that we have graphed everything. We would start at -4 with an open circle. We'd look at our inequality and realize that it says that it is equal to, which means that that value can be an answer, so we fill in our circle to represent that 4 is an answer to this inequality. And we have m is greater than -4, and off to the right is all the values that are greater than -4, so that would be our graph. So the next thing I want to do is I'm going to just show you why it is that we need to change the direction of the inequality. So I'm going to erase the left-hand side where we solved our equation. And we're going to do a little bit of a check your work kind of thing. What I'm going to do is I'm going to look at the problem that we just solved, and I'm going to realize that if I want to check my work, according to what I have here, any value that is greater than -4, I should be able to put into my original inequality, and it should come out as a true statement. Since I don't particularly care for negative numbers a whole lot, I'm going to use the value of +1. So I'm going to take +1, and I know that 1 works because 1 is greater than -4. So I'm going to take my +1, and I'm going to put that back into my original inequality. So let's go ahead and do that. We're going to have -2, and instead of m, I'm going to substitute in my value of +1, and I have is less than or equal to 8. So if I solve this, then I get -2 is less than or equal to 8, which of course works. And some of you are probably saying, well, how do you know it doesn't work if we don't change the sign? So let's do that also. If I had in the original equation, original inequality, not changed the direction of the symbol, then it would have been written as m is less than or equal to -4. And you can see that just by looking at the previous problem and seeing that that's what it used to be, is less than or equal to. So if I have m is less than or equal to -4, and I try to substitute a value in for that, then I would use a value of, let's say, -5, because that is less than -4. So I'm going to use that value and substitute that into my original inequality. So I'm going to have -2, and instead of m, I'm going to use a value of -5 is less than or equal to 8. Now hopefully you see this already, but if not, let's go ahead and finish this off. If I solve the rest of this inequality, I'm going to multiply -2 times -5, and I'm going to get a value of +10, because a negative times a negative is a positive. Which means my inequality would read that 10 is less than or equal to 8, which of course is ridiculous because 10 is not less than or equal to 8. So that shows you that when you multiply both sides of an inequality by a negative value, which we did by multiplying by 1 over -2, that we have to change the direction of the inequality just to show that something has, that is where the values are that will actually answer this question correctly. There we have solving and graphing one-step inequalities, and I hope that helps you all. I will talk to you tomorrow.